IGCSE Computer Science Syllabus Statement 1.1.1a, recognize the use of binary numbers in computer systems. So, for this course, you need to know about binary. So that's one of the main aspects in this sort of the foundation. So, the basic building block of computers is binary. But what is binary? Well, binary is a number system. So everyone should be familiar with the decimal number system, which is our number counting system. So we have numbers 0 to 9, and then 10, 11, 12, and so on. Well, binary is like that, but it's binary, so it's base 2. Our counting system is what is known as base 10, but binary is base 2. So what that means is we know that our number counting system, when we start with one digit, when we get to 9, and we want to add 1 to that, when we want to go to the next value after that, we add another column to the left, we turn the 9 into a 0, and then we put a 1 on the left. That's pretty much how base 10 works. It's binary, it's like that, but 2. So there are only 2 possible values, which are 0 and 1 for each digit. Computer systems have millions of switches, which can be off or on, and this logically lends itself to binary. What this means is, if you think about your computer, which is in front of you right now, like it could be a phone, a laptop, or whatever, like it contains millions of tiny switches, which can be off or on. On meaning electricity passes through it. So when we say that it logically lends itself to binary, we say that 0 represents off and 1 represents on. So you can kind of see how binary would work with the system quite well. So it's like a light switch in your room. So like a 0 would be lights off, 1 would be lights on. So again, our number system is decimal base 10. So an example of a decimal number would be 36. But in the computer number system, binary, base 2, a binary number would look something like this. And in fact, this is the equivalent to, this binary value is the equivalent of the decimal value 36. And we'll get to converting binary and decimal values in the next video. So we have this thing here. To better understand how the decimal system works, each of these represents a sort of digit, column for a digit. So each column is a digit, really. So here we have 10 to the power of 0, which gives 1. 10 to the power of 1 is 10, and so on. It's basically 10 to the power of n, and it keeps going, left. As we go left, the n increments, so we get these. Now what this basically means is what we're actually going to do is get to this in the next video when we look at conversion, so it better makes sense. What makes better sense? Does better make sense? Does that make sense? But binary is this, but with 2 to the power of n. So you can see base 10 is 10 to the power of n, base 2, 2 to the power of n, and we get these decimal values here. So we're actually going to better understand this in the next video when we look at conversions.